Okay, guys, your quiz is on Thursday. How many questions are on your quiz? 10. 9 of the 10 questions say to do what? Solve. Okay, so 9, solve. What does one question tell you to do? Solve how? Completing the square. You have to show you know how to complete the square. Super duper important. So what we're going to do today is kind of talk about how you should approach these problems. If you come to something like number one is a quadratic. It's x squared. You should have how many answers for a quadratic? 2, okay? Because the highest exponent is going to tell you how many. You cannot solve this by just taking the square root of each side because you have x to the second power and x to the first power. So your only 2 options are to move the 4 over. So 5x squared minus 12x, then what? Plus 4 equals 0. Your 2 options are to A, factor, or to B, complete the square. If you like completing the square, it'll work every single time. If you're not super pumped with that, then I would try to factor and hope that this does. So if we're going to factor this, 5 times 4. What are the factors of positive 20 that multiply to give you 20, but add to give you a negative 12? Negative 10 and negative 2. Okay, I'm going to do this one both ways. I'm going to do it the grouping way first. So 5x squared minus 10x, right? Minus 2x plus 4. So if we group the first 2 and you group the second 2. What can I take out of 5x squared minus 10x? 5x, perfect. And you're left with x minus 2. All right, what can I take out of negative 2x and a positive 4? Negative 2, and we're left with x minus 2. So I have x minus 2 one time out in front, and then my leftovers get their own parenthesis. So 5x minus 2 equals 0. And then what do I do with those 2 parentheses? Set them equal to what? Perfect. So 5x minus 2 equals 0. So I get x equals 2, and x equals what? Positive 2 over 5. Now, if you did it the other way that I do, you would just have x, minus 10, x minus 2, and then you're going to divide both sides here. So you get x minus 2 and 5x minus 2. Either way, guys, same thing. But remember, if you have a quadratic, come out with 2 answers. But if the problem says solve, you have to determine what would be the best thing to do. Look at number 2. Negative 3x minus 1, quantity squared equals 48. Some of you are going to say, okay, well, doesn't that mean I have negative 3x minus 1 times negative 3x minus 1? We FOIL it out, move the 48 over, see if it factors. That's not the best way to approach this. If you have a binomial squared equals to a number, what's the best way to solve this problem? To take the square root of both sides. All right, guys, when we take the square root of both sides, what do we absolutely have to remember to do? The plus or minus, so important. So negative 3x minus 1 equals plus or minus square root of 48. Now we're going to move, we want x by itself, so I'm going to add 1 to both sides, good. So negative 3x equals 1 plus or minus the square root of 48. And then the last thing is divide by negative 3, isolate the x, good. So x equals 1 plus or minus the square root of 48 divided by 3. What do I do with the square root of 48? Can I leave my answer like that? No, 48 breaks down into 16 times 3, right? Did I forget the... Wait, say it again? It didn't. My pen's not working with me. My good one, my daughters were using and can't find it right now. So I'm using this one that just keeps like turning off and stuff as I write. So thank you. All right, how can I break down 16? 4. Okay, so this becomes 4 root 3. So it's x equals 1 plus or minus 4 square root of 3 over negative 3. If you guys want to split it, you can. You don't have to. You can have 1 over negative 3 plus or minus 4, God bless you, root 3 over negative 3. But I would just leave it just like that. Perfectly fine. Yeah. All right, number 3. Basically the same problem. What's the most efficient way to solve this problem? Take the square root of both sides, okay? So we're going to do that. Excuse me. We're going to do that. Take the square root here, square root here. So I have 3x plus 5 equals plus or minus. Fantastic. Plus or minus square root of 48. I'm going to subtract 5 from both sides. So 3x equals negative 5 plus or minus the square root of 48. Then what? Divide by 3. Good. So x equals negative 5 plus or minus the square root of 48 over 3. Do I leave 48? What does that break down into? 16 and 3? So 4 square roots of 3. So x equals negative 5 plus or minus. See, I said negative and it didn't go. Negative 5 plus or minus 4 square roots of 3 over 3. Last period we did number 4, and 2 people solved it completely differently and got the same exact answer. What's one way that you could approach this problem? Subtract 9? Okay, perfect. We can subtract 9 from both sides. So when we subtract 9, we have 5x squared minus 15 equals 0, correct? This is solving by factoring. Perfect. So how do I factor this? What do you take out? 5. Good. So you have x squared minus 3 equals 0. Is that the difference of perfect squares? No. So we can't break it down at all. So now we just set each piece equal to 0, correct? So 5 equals 0. True? No. Just cross it off. X squared minus 3 equals 0. So x squared equals 3. What do? Take the square root. Perfect. So x equals plus or minus the square root of 3. What's another way we could have done that? You could add 6 to both sides, right? So if I added 6 to both sides, I get 5x squared equals positive 15. All right, isolate x squared. What do? Divide by 5. Perfect. So x squared equals 3. Then I do what? Take the square root. So x equals plus or minus the square root of 3. Is that the exact same answer? Yes. Does that mathematically make sense? Yes. Either way you would have solved that problem, you would have gotten full credit for it. It makes total sense. You can solve by factoring here, or you could solve by square rooting. Same exact thing. Does anybody have any questions on that? The only one that you have to absolutely solve one specific method is where it tells you solve by completing the square. All right, this next question I want you guys to pay attention to. All right, this is not an Algebra 2 concept. This is a Algebra 1 concept that we have to understand. That 2/3 is being distributed to everything in here. I'm going to go ahead and distribute the 2/3 to prove a point here. If I distribute the 2/3, I have 2/3 x minus 2/3 equals negative x minus 5, correct? We don't like to deal with fractions. So what am I going to multiply the whole equation, left and right hand side by? 3. Okay, I'm going to multiply everything by 3. So think about that. When I multiply to this first term, 3 times 2 is 6. 6 divided by 3 is 2. So this is 2x. Minus, if I multiply 3 here, 3 times negative 2 is negative 6. Divided by 3 is 2. And then I have to multiply the 3 here. Correct? 3 times negative x is negative 3x. 3 times negative 5 is minus 15. Everybody see how that just happened? Last period, I'm going to come back to this in a second. Last period said, okay, 2/3, and then we went x minus 1 equals negative x minus 5. And they said, well, can't you just multiply the whole thing by 3? Absolutely, guys. If we multiply this whole thing by 3, what's happening here? You're distributing the 3 here, not to then here and here as well. You have to distribute the 2/3 for, if you're going to just go ahead and get rid, or you have to understand that this is going to cancel out here. The pen keeps dying. Cancel out here, and then the 3 is going to go over here as well. So if I were you and you're trying to get rid, like, because this is also the same thing as saying x minus 1 times 2 over 3. Right? That 2/3 is on the outside, but it's that x minus 1 is stuck together with a parenthesis. So if you were to do it this way out here, you're not distributing the 2/3 You're not distributing that 3. I mean to the 2/3, to the x, and to the -1. I would distribute the 2/3 first so you see, oh, okay, I see where that 3 is going to go. That's all I'm saying. If you want to keep working with fractions, you can. You're absolutely able to. Just turn everything into thirds. God bless you. But that's not the easiest thing to do. Or rewrite it so it's 2 times x minus 1 over 3. So you see what you're trying to get rid of is that 3 that's underneath that whole thing. That's one term right there. That parentheses tells you, hey, this sticks together. It's not that they're all separated by plus and minus signs. So once we get here, this is a super easy problem. What do I do? Okay, you want to add positive 2 here and add 3x. So we have 5x equals negative 13. And then what? Divide by 5. Do we think that we did something wrong since we got a weird answer like negative 13 over 5? No, it's okay. You're not going to always get beautiful whole numbers. You're going to get fractions sometimes. Negative 15 plus 2 is negative 13, right? And then 2 plus 3 is 5.
Yeah, but like, wouldn't x equal 13? You're trying to get a negative number.
Huh?
You're trying to get a negative number. Like, oh wait, never mind. I just completely.
It's just negative 13 over 5.
Yeah, I got it.
You're, okay. No worries, no worries. How many answers should I get for number 6? 1. What's x? What's the exponent on x? 1. If you have x to the first power, you're going to have 1 answer. If you have x to the second power, how many answers? 2. X to the third power, how many answers? 3. Okay, so be mindful of that. You're going to have a question like this. Might have an extra bracket or something like that. I did a quote-unquote bonus question. There's not any bonus on the quiz. I just gave you an extra question on the review to see. But this question is asking, do you know order of operations? Can you work from the inside out? So where do we begin? What should I do first? The parentheses. Can I simplify anything in there? X minus 1. No. So move to the outside. What's just outside of that? The negative 4. Let's distribute that negative 4. So I have negative 3x minus 4x. What's a negative 4 times a negative 1? Plus 4x plus 2 equals negative 8. Combine like... Yeah, I don't know why I put the x there. Sorry. Combine like terms. What can you combine?
4 plus 2 and then the...
Yeah, the 4 plus 2 is going to give me a positive 6.
And the negative 3.
Negative 3 and negative 4 is going to give me negative 7x equals negative 8. Okay. Now what? Subtract 6. Perfect. So negative 7x equals negative 14. What's x equal? Positive 2. Divide both sides by negative 7. Negative divided by negative is a positive. Is it imperative? Do you absolutely have to check any of these answers so far? No. Can you? Yes. When you get x equals, you can check. But when do we have to make sure we check? When what? Okay. Not necessarily when there's 2. What type of problem do we have to make sure that we're checking? It's on this page. Say it again. Rationals. Why do we have to make sure we have to check our answers when we have rationals? Correct. You can get an answer that says x equals something, but you plug it back in, it makes your denominator 0. So many of you came up to me on your WebAssign, you're like, WebAssign keeps marking this wrong, and I know I'm right, x equals 1. And I said, well, what happens when you plug 1 back in? And you're like, oh, the denominator becomes 0. You guys are going to have stuff like that in the quiz, so you're going to have to check. All right, let's talk about this one. How many answers? 1. Okay, where do I begin? Okay, let's distribute that negative 2. So I have negative 2x. What's negative 2 times 4? Negative 8 plus 3x equals x minus 9. Now what? Negative 2x and 3x is x minus 8 equals x minus 9. Okay, right there, somebody just said no solution. If you see that's no solution there, perfect. If you're like, wait, I'm not 100% sure, go ahead and keep solving. Luna, what do you want me to do? Plus 8, okay. And subtract x. So over here I have 0, and over here I have negative 1. Is that a true statement? Is 0 ever equal to -1? So your answer here is no solution. Guys, if you get a no solution, you have to write no solution. If you just leave 0 equals -1, you're getting points off. You have to know that that indicates there is no solution to this problem. All right, this didn't happen. This is just an example. What about if you solved your equation, you came out with this? X minus 8 equals x minus 8. What's the answer to that? All real. You can say all real numbers, infinite solutions. If you weren't 100% sure and you go ahead and say, okay, I'm going to subtract x from both sides, add 8 to both sides, you get 0 equals 0. Do you see the difference between 0 equals -1 and 0 equals 0? When will 0 equal 0? All the time. That's why it's all solutions. It's very important that you guys see the difference between those two answers. You will see stuff like that on the quiz. I'm not saying every version is going to have both or every version is just going to have one, but it's a possibility that you guys will have no solution and or all real numbers. Just pay attention to that. All right, let's do a rational one. Write this down, please, because some of you just keep forgetting to do this. When you have a rational, what should you do absolutely first? Before you get a common denominator, guys, you have to factor. Some of you would tell me my common denominator is x minus 2, x squared minus 4, and x plus 2. That's not true. You have to get a common denominator after you factor. What can I factor x squared minus 4 into? Plus 2 and minus 2. Now it's really easy to see what your common denominator would be. This is just my side work over here. What is my common denominator going to be? X plus 2 and x minus 2. Once I make the denominators the same, what can I do to the denominator? Like in what? Once the denominator is the same, do I pay any attention to it anymore? No. So let's talk about my first fraction has the x minus 2. What is it missing? X plus 2. So if you multiply the bottom by x plus 2, you have to multiply the top by x plus 2. My second fraction has both. Do I have to do anything? Stays the same. All right, what about the last one? I have to multiply the x minus 2, top and bottom. Now, guys, if you notice, the denominators are all the same. So you have just created equivalency on either side of the equal sign, so you just deal with the numerator. X plus 2 minus 2x minus 3 equals 5 times x minus 2. Okay, little things that are going to pop up that are going to get you. Why did I keep this expression inside of a parenthesis? Because of the negative. A lot of you guys skipped a step, and then what happened? You forgot to distribute the negative, which then messes up the entire problem. So just be careful with little things like that. Let's go ahead and distribute. 4 times x is 4x. 4 times 2 is what? 8. Whoops, I forgot to put a plus sign. Now that negative, what does this become? Minus 2x plus 3. Perfect. And then? Perfect. 5x minus 10. Combine like terms. What do we have in common? 4x minus 2x is 2x. 8 plus 3 is, good, equals 5x minus 10. I'm going to move x's to the left, so I'm going to subtract 5x minus 11, and I get negative 3x equals negative 21. Divide both sides by what? Negative 3, and x equals 7. Do I know for sure 100,000% that I'm right? What do I have to check? X equals 7. Where do I need to put it? I need to put in each x in the denominator just to make sure none of the denominators become 0. So I put a 7 here. 7 minus 2, not 0. Put it here. 7 squared minus 4, not 0. Here, 7 plus 2, not 0. We're good. What would happen, just say, not happening, but an example, what if I got x equals 2 as an answer? 2 minus 2 equals 0, so then you would cross this out and say no solution. You have to check the rationals. I'm stressing that to you guys for a reason. If you get an answer that could possibly make a denominator become 0, you have to check. Yes, ma'am?
Why would the answer be all real numbers?
When the left-hand side of the equation is exactly the same as the right. So like here, do you see how x minus 8 is that equals x minus 8? That means anything you plug in for the x on the left-hand side is going to make the right-hand side true. If you go ahead and solve it, you get 0 equals 0. That's when that happens. All right, here's a little bonus one because you're going to absolutely 100% have a question that says solve by completing the square. Okay, so when we complete the square, what we want to happen is that our x squared has a positive 1 as its coefficient. Does it? Yes, so we can just go proceed. What do I do with my negative 2? I'm going to add it, move it to the other side. So I have x squared minus 3x plus the big old box equals 2 plus the big old box, or square, however you want to say it. Now we're going to form our perfect square trinomial over here. I take my b term and do what? Negative 3 divided by 2. So what's going to go inside of my parenthesis? X minus, what goes inside the parenthesis? X minus 3 over 2. And that's quantity squared. Now, how do you figure out what goes in the box? What do you do to negative 3 over 2? You square it. So what is negative 3 over 2 squared? Positive 9 over 4. Last period, somebody put negative. Guys, when you square a number, it's always what? Positive. Come on, little stuff like that. Pay attention to. So now, before we combine those, 2 plus 9/4, what do I have to do? Common denominator. What's my common denominator between 1 and 4? Can I just do 4? Okay, so if I multiply the bottom by 4, 4 times 1 is 4. If I multiply the top by 4, 2 times 4 is 8. So now I combine, and 8 plus 9 is 17 over 4. Now this is a problem we've done a bunch of times. I have a binomial squared equal to a number. So what do I do to both sides? Take the square root. So x minus 3 over 2 equals what? Plus or minus, fantastic. Square root of 17 over 2. Wonderful. And then one more step. Add your 3 over 2. I like to write it with the number first. So 3 over 2 plus or minus square root of 17 over 2. Yes.
How do we get the 2? Oh, wait, never mind. I got it.
Okay. If you would like to write this as x equals 3 plus or minus the square root of 17 all over 2, you can, but you don't have to. Either way is fine. Either way is fine. Now, I want to just bring one more thing to your attention, and then the rest of the class period is yours to work on homework or the review or whatever you want to do. Ask me questions. But, look at this. Write this down real quick. Or just watch. Doesn't matter. Okay, say we're completing the square. Say you have a question that starts off like this. You have a binomial equal to a number, right? A binomial squared equal to a number. So what do? Take the square root, okay? We've done this a bunch. So I have x minus 2 equals plus or minus, right? You guys know the square root of 8? Is it a perfect square? No, there's one inside. We'll talk about that in a minute. Over the square root of 3. Is this okay? No. From about the second or third day of school, guys, we have been rationalizing denominators. You've seen it on every quiz. You've seen it on every test. You cannot leave a radical in the denominator. So before you go any further, you need to fix this. What do I multiply the top and bottom by? The square root of 3. Square root of 3, square root of 3. So I have x minus 2 equals plus or minus. What's 8 times 3? So 24 over 3. Everybody see that? Now we can proceed. What?
Why didn't we do that to 17 over 2?
Because the 2 was a whole number in the denominator. The square root of 4 is 2.
Oh, okay.
This is if you have a radical in the denominator. So if we proceed from here, guys, we're going to add 2 to both sides. So I have x equals 2 plus or minus the square root of 24 over 3. What's the next thing I need to do? What do I have to fix? The 24. The square root of 24 is 4 times 6, correct? Yes? So I'm going to take that 2 out. So what your answer is x equals 2 plus or minus 2 square root of 6 over 3. Notice where the 3 is in the denominator. Is it under the entire expression? No. The 3 is only under the 2 root 6 because that's the only thing that's affected. That whole number 2 does not have a denominator. You can leave it just like this. Somebody asked me last period, well, can you write it with everything over one denominator? Absolutely, but what would you have to do? You'd have to make the 2 into what? Yep, you would have to say x equals 6 plus or minus 2 square root of 6 over 3. Because the whole number 2 is the same as 6 over 3. There's absolutely no reason to do that. If you do, guys, if you try to simplify or you try to break stuff down more so than you need to and you do it wrong, you're going to get points off. You have to know when to stop simplifying or how to simplify properly. Not sure what's going on next door. It's not Miss Thompson. She's right here. Sure. All right, so I recorded this. I'm going to post it on YouTube. The video of me working everything out is on YouTube. Please, guys, go to WebAssign, look for extra practice problems. Anything you have questions on, we're going to go over it tomorrow. Yes, ma'am.
For the number 9, over there, is it all if I do 3/2 plus or minus 17/2?
Yeah. Yeah, you can leave it separated or you can write it together. It doesn't matter. Some people, they just like it all together, which is fine. But the problem is when you have a whole number, you have to change that whole number to whatever denomination the denominator is. That's why I did that one. You see how this one is already, like it was 3 over 2 and 17 over 2. They already had the same denominator.
Yeah.
Here, they didn't. So you have to, if you want to write it all together, you have to make it the same denominator. That's why I did that one.
I can still have
Yeah.
it. Oh, okay.
Yeah. Okay.